Guys, here we are. We're in chapter 10. We're looking at circles and circumference. So these bits of vocabulary and information need to be memorized. Make sure you have it. Hopefully, everybody should be relatively familiar with this shape. No, it's not a potato, it's a circle. So this is a circle. A circle is defined as a set of points in a plane that is equidistant from one point. So if you think about it, you can kind of think of each of the points that make up the circle is in one plane, and each of the points, let's say 3 inches, is equidistant from that center point. Does that make sense? Okay, hopefully so. Let's see. So now that we know what a circle is, I guess we should kind of backtrack and talk about the center of the circle. So the center of the circle is exactly what you think, that dot in the middle, or the point for which all of the points are equidistant, right? Then we have the radius. The radius is the distance from the center to the one of the edge points of the circle. And so the radius, I will highlight here in green. Let's do a better job of that, is that thing there. All right. Okay. Let me exaggerate this red center. Okay. So then a chord is the connecting or the connection of any 2 points in the circle, on the circle. So a chord can be seen when I draw this line from here. Let's just take 2 points on the circle. These 2 points connected together create a chord. Let's actually connect them. These 2 points connected together, this segment that I've created is a chord. And you know, we can have infinitely many chords, right? Here's a chord right there. I'm going to remake that chord because this chord is a special chord. All right. So this chord is the diameter. This chord is the diameter. The diameter is a special chord that connects 2 points on the circle, but it passes through the center of the circle. So even though both of these are blue, notice that the diameter is highlighted with some wiggly lines and some extra stuff. So you've got chords. Anything that connects 2 points on the circle is a chord, but if it goes straight through the center, it is a diameter. And what I want you to see about this is that the diameter, I'm going to use a capital D, is, or maybe lowercase d is better, the diameter is equal to 2 times the radius, right? Because if I take 2 of these guys in lengths, right, if I were to draw another radius from here to here, let's say, that would simply be a diameter as well. You guys with me? All right, let's keep going. When I consider the idea of the concentric circles, it really is several circles that have the same center. And I guess I'm thinking about the Target logo, right? So concentric circles would be kind of like a bullseye, where you've got several circles that have the same center. And when we talk about the circumference of a circle, let me get back to my highlighter here. When we talk about the circumference of a circle, we're talking about the distance around the edge. So if I were to talk about the circumference of this circle, I'd be talking about the length around the circle. Circumference has a formula, and that formula is given as the circumference of the circle is equal to pi times the diameter, right? You've heard of pi, but let's define pi. Since the circumference is equal to pi times the diameter, what we know is that, with a little bit of algebra, we can prove to ourselves in a way, that pi is equal to the ratio of the circumference divided, well, is equal to the ratio of the circumference to the diameter. So pi is a number that is equal to the ratio of the circumference to the diameter. Right now you might be saying, wait a minute, I've always been told that pi is 3.14, continuing on. I'm sure some of you right now are like, I know all the numbers of pi, I can do it. Or at least not all, but many of them. I can't, it's not my gift. But you're right about that too. See, the thing is, when you take the distance around a circle, if you could like go and get yourself a can at your house and you take the distance around that circle and you measure it really, really well, and then you measure the diameter of that can really, really well, if you do that, you're going to get the value of pi that you guys probably have heard of. It goes on forever and ever. And if you're like so interested, you can go to Google and Google Pi, and they can give you the first million decimal point numbers after the decimal point. And so we know when numbers do weird stuff like this. I'm going to erase all this. We know when numbers go on forever and ever without repeating after the decimal and without any kind of noticeable pattern, right? If non-terminating, non-repeating decimal, when we have that, we know that this is an irrational number. So I just want to, bring that home a little bit. Irrational number. All right, we're getting here. We're getting here. Almost done. Two more words. Inscribed and circumscribed. So sometimes we can have a figure inscribed within a circle, and a figure inscribed within a circle would be a figure that's inside the circle and they meet but they don't cross. So like this triangle is inscribed within the circle. It meets everywhere. I'm not doing a particularly neat job here, but it doesn't cross out of the circle. The entire triangle is contained within the circle and on the circle. So that is an inscribed triangle. And sometimes you can have things that are circumscribed. Circumscribed is kind of the opposite of inscribed. It does the same thing. It meets outside of the circle. All the sides touch. That's not a good example. Let me try it again. All the sides touch at a point. I am trying my best, my friends. There we go. There we go. Not really. Okay, you get where I'm going, right? So all the sides touch exactly one point. There's no like hovering circle inside. The circle is totally there's a word we're going to use later in the chapter called tangent. Each of the sides are tangent to the circle. They touch at just one point. So inscribed is a triangle. Circumscribed is this quadrilateral, which looks kind of like a trapezoid. So let's go with that. All right, that's it for vocabulary. It took a long time. Memorize these words. Make sure you have them, and they'll be helpful for your assignment. All right, let's take a look at a couple of example problems. So the first thing, we're supposed to name the circle and identify the radius. Well, how do you name circles is the question that you might want to ask. When you name circles, you name them by their center. So this would be called circle P. Circle P can be written like this or with circle P, like that. And now we're supposed to identify the a radius, and you can see we've got several choices. PN, radius PN. I think that's good enough for us. And that's going to be a segment. Notice that the center is named first, and then we talk about the end. So radius PN, radius PL, radius PM. PM could have been other choices. Identify a chord and a diameter of the circle. So I could say HG for both of them, right? Because we know that a chord is a diameter. But let's be all fancy about it and say that we have a chord JK here. That's our chord. And then our diameter would be HG right here. All right, so here in example, what is this, example 2, we're going to find the radius and diameter. If QV, this segment here, is 8 inches long, and anytime you have a geometry problem or a figure, you want to start writing right on the picture. I've said that before, but I want that to be a thing that you do, as long as it's not like a textbook you've got to return or something. What is the diameter of circle Q, this particular circle here? And we talked before that we know that the diameter is equal to 2 times the radius, and so there's no question that if we were to extend this and make this a diameter, that the diameter would simply be 2 times 8, and therefore the diameter would be 16 inches. So sometimes I like to come back to these key things from your textbook, which I think are really nice, because it does simplify and kind of take and condense all the information. So let's just take a look. Two circles are congruent if and only if they have congruent radii. And that kind of makes sense. To have the same size circle, you need to have the same size radii, and therefore they're congruent. They can lay on top of each other and, one hide the other. So GH and JK have to be congruent. All circles are similar, which makes sense. All circles are visual enlargements or reductions of other circles, which totally makes sense as long as you're a real circle and not a weird potato thing that I've drawn. And concentric circles are coplanar, circles that have the same center. And I don't think I said that when I gave you the definition, so sometimes I also like to read through this. I didn't say they were coplanar, meaning they're all in the same plane. So if you had, I'm picturing like those windmill thingies that you have outside, that sometimes you start off with concentric circles if you lay them flat, but if you hold them up, they kind of form like a globish type thing. If you don't know what I'm talking about, don't worry. Just know that they do need to be in the same plane. Same circles that have the same center and in the same plane. All right. So that brings us to another concept that we should have. There's a finite number of ways that circles can intersect. You can have circles that intersect in a single point. They intersect in 2 points, right? This is if they're not the same circle, not the same congruent circle, or they don't intersect at all, and they can be concentric like this, or they could just not actually intersect. Just mental picture of circles that we should keep in mind. All right, so here we have a situation where we do have intersecting circles, and they do intersect in a couple of points here. All right, so the diameter of circle S is 30 units. So I like to write that information in as soon as I get it. So I'm going to put that here. This diameter from here to here is 30. And then circle R is, the diameter of circle R is 20 units. So from here to here is 20. And then they tell us that DS, this little bit here, is going to be 9 units. So right there is 9. And we're supposed to find CD. So zooming in, here's our situation. Diameter is 30. I think they said diameter. Let me get that back again. Okay, kiddos, I messed that up. The diameter here of this guy is going to be 20, not the radius there. And I'm glad I'm showing you my mistakes, because we all make them. All right, good. So the diameter here is 20 and the diameter here is 30. We have to find this little bit here, which is our which is our CD value. Got me? Okay, good. So now that we have that, what I can do is I say if the diameter is 20, then the radius here has to be 10. This is getting a little convoluted, but just stay with me. And I can also say from C to S, that has to be 15, right? Well, that actually does a lot for me. So from C to D is 10, and from D to S is 15. Well, if from D to S is 15, if C to S is 15 and D to S is 9, then clearly CD is just going to be the difference between the two, which is going to give us 6. Now here's my thinking. I think they actually did not intend to ask this question. I think they wanted us to know what RC was, because that's the harder problem. Because honestly, we didn't even need to know about this 20 units R here, because I think that's what they wanted to do. So we got the answer. Yay! I'm going to ask you guys a supplemental question right now. Could you tell me what RC is? Could you tell me what RC would be? What's that length going to be? Right? So if we calculated that from here to here is 6, and we see that R to D is the radius, which is 10, then RC has to be 4. This was not the question that the textbook asked, but I think it's the question that they meant to ask. CD is 6, and we just got that from subtraction. The last concept we're going to talk about is finding the circumference of a circle. Circumference is equal to pi times the diameter, or 2 times pi times r, and that makes total sense to us because we know that the diameter is equal to 2 times r. So with that, I think I'm going to use a second video to do examples with the circumference, so stay tuned for more.